So let's begin to think about this idea. Okay, so if we are dealing with a situation in where we would have more than one independent variable, this is actually a very common thing that happens for us in terms of psychological studies. So think, for example, to yourself in terms of your performance on an exam. If we were to think about your performance on an exam, would we say that there's only one factor that would potentially predict your performance on the exam? Or would we say that there may potentially be multiple factors? And your answer should really be, well, there's going to be multiple things that may potentially affect my performance. Well, what are some of those multiple things? Well, potentially, how much sleep did you get? How many hours did you study? Did you read the book? Did you look at the lectures? Did you do the homework assignments? Did you perform well? Etc., etc., etc. All these different factors now are ultimately contributing to our ultimate assessment effect that we're gonna actually see, or our dependent variable score that we're gonna end up having in terms of our assessment performance measure. So here, when we actually look at all the things that we've been doing up to this point in the semester, that for instance, when we looked at t-test, the effect of gender on aggression, the effect of stress on memory performance, and even when we looked at ANOVA and we had all these different categories associated with our independent variable, we were still dealing with one independent variable. So in reality, that one single independent variable and the way it affects one dependent variable is not really the way that we do a lot of research in terms of psychology. So in other words, again, having one single predictor, so having one IV, and then it directly affecting my dependent variable, yeah, that may potentially happen, but in reality, there's probably going to be multiple independent variables that are all going to be combining together that are going to be creating this effect on my dependent variable. So the combination of independent variables are really going to be having an effect on my dependent variable. So again, think about your exam performance. So what is your exam performance going to depend on? Well, your exam performance is going to depend on a lot of different factors. Again, number of hours studying, so number of hours, your fatigue levels, so if you are fatigued or not, um, reading the chapters, and all of these different factors all together are going to combine to create your score on the exam. And ultimately, this is the real world that we live in. So this is the world that we actually live in when we think about psychological constructs. So when we think about, for instance, treating somebody with depression, it's not like if we say there's only one single causal mechanism that's ultimately having the effect on this individual having depression. Rather, it's going to be multiple factors that are going to be working together that are ultimately going to have an effect in terms of their behaviors. So in clinical psychology, we encounter a term very frequently that's called comorbidity. And comorbidity essentially means that multiple things are happening at the same time that are ultimately affecting the behavior. And that's ultimately what we're seeing here. That when we think to ourselves, okay, well, what does your exam performance depend on? Well, it depends on a lot of different factors. So that's why when I told you at the beginning of the semester that, oh, one of my favorite answers in terms of answering any question is really, it depends. Well, what does it depend on? Well, it depends on a lot of different factors. One of the questions I get in intro to psychology that always kind of makes me laugh is that I'll always get somebody who says, oh, well, how am I going to do, or what's my memory going to look like? Or how am I going to do on an exam? If, let's say, for instance, I haven't slept in 8 hours, or I haven't slept in 8 days, I've had alcohol in my system, I've had some illegal drugs in my system, and I really haven't studied for the exam. And then people say, what's my performance on my exam going to look like? Or what's my memory going to look like? And you just kind of stay stunned and you're like, well, I don't know. Like that's a really interesting question that and the answer that we normally give is it depends. And people will normally get upset and people will be like, oh, well, why don't you just give an answer? Well, because it's really difficult for us to determine what the answer is. Because if we think about it, okay, so you haven't slept in 8 days. Is that typical for you? If it is, well, then it's really not going to have that much of an effect. But if it's not typical of you, okay, well, then that's a problem. When you say that you've consumed alcohol, well, how much alcohol have you consumed? Have you had one small beer, or have you had a 40-ounce beer? I mean, that's still technically one beer. So I mean, well, what's the answer? Have you had just one small, 12-ounce beer, or 40-ounce one beer? You've had illegal drugs in your system. Well, what kind of illegal drugs? What's the purity levels associated with those illegal drugs? Do you have a tolerance level to those illegal drugs? What's your gender? What's your weight? What's your height? Because all of those factors are going to ultimately create the effect that we're going to see on something like an exam performance or on a memory score. So we would assume here that people just assume that, well, it should be a really simple kind of linear effect that we say, well, this is the factor that we're considering, this is the effect that we're ultimately going to see. But in reality, we have multiple independent variables that are really going to be affecting our performance in terms of our exam. So now we start noticing here that in the real world, it starts getting a little bit more complicated for us in terms of discussing what effects really do look like. So in other words, what do results look like out there in the real world? Well, they become complicated because we have to deal with so many independent variables, and that's really the world that we live in. So we live in a world where we deal with so many different independent variables, and we have statistical analyses that allow us to deal with that. So here is really where we take a step forward now when we say, okay, we were dealing with one independent variable, now we're dealing with multiple independent variables. So if you remember, in one of our when we looked at the tree at the beginning of our discussion, we looked here at this idea of, okay, well, you're dealing with multiple groups, and then you have independent samples and you have related samples. So we've already talked about the one-way ANOVA, and we've already talked about repeated measures ANOVA. But now here we're saying, okay, well, how many independent variables are you working with? Are you working with one independent variable? If you are, you're going to do a one-way ANOVA. Again, that's why we called it a one-way ANOVA, because it had one way, one independent variable because of the wayness. But now we're dealing with multifactorial designs, or a multi-factor ANOVA. What does that mean? It means that we're dealing with multiple independent variables and their effect on one single dependent variable. So ultimately here, we start seeing now that this is the way that we actually work in the real world, that this is a very frequent analysis that we do in terms of trying to understand what something as simple as what's your memory going to look like, or how are you going to perform on an exam. That there's so many different factors that are ultimately going to affect your performance that here we really do have to look at this idea of a multi-factor design or a factorial ANOVA that we really want to look at. So when we think about these ideas of factorial designs and multi-factor designs, what are we really looking at here? The key issue that's really of concern for us is the number of independent variables that we're going to be using in our research study. So again here, I talk about the interaction and the close relation between a research design for a research study and your statistical analysis. And I do realize that even though you are going to take research methods in the future as another course, here I still want to introduce some of these ideas of research design to you because it's so important to understand those key fundamental elements that are basic terminology and basic issues for the foundation of research methods. So when we think about having one single independent variable, this is normally where we're going to have something that's called a single factor design. So whenever it is that you hear anybody say in the research literature or in a presentation, we had a single factor design, that means that they had one independent variable in their research study. And normally they have one dependent variable as well, but here the key issue is the number of independent variables. So here they're telling you I only have one independent variable. Now, whenever it is that we look at this idea of a single factor design, it's very important for us to also understand what it is that we're able to examine with a single factor design. And to be honest, single factor designs are quite limited in terms of what they can offer for us. And why is it that they're limited? Well, they're limited because they really can't describe too much information. Think of independent variables as being pieces to a puzzle, okay? So each independent variable is a piece to the puzzle. So if we only have one single piece of that puzzle, it's very difficult for us to get an entire picture of what the puzzle is supposed to look like, right? So here, if we're considering, something like memory to be the entire puzzle, and that's the entire picture I want to look at, having one single puzzle piece is going to be very, very difficult for me to try to understand what the entire picture is supposed to be. Well, that's what a single factor design really does. The single factor design gives you one single answer, and it gives you one single piece to the puzzle. So ultimately, all it's really going to tell you is it's going to tell you the following. It's going to tell you this is the effect of that independent variable on the dependent variable. And that's it. Nothing more. So here, think of it again as being that one single puzzle piece, that you put down a puzzle piece on the table that's blank, And you say to yourself, well, great, now what? Well, you need another puzzle piece, you need another puzzle piece, and another one, and another one, and another one. And now you start combining them all together, and it starts providing you with a clearer picture. But if you only have one single puzzle piece, all it's going to allow me to do is look at the effect of that one single factor, that one single puzzle piece, how it affects the entire puzzle, or how it affects my dependent variable. So in other words, all that a single factor design can do is it's going to say, how does gender affect something like aggression? Now, this is a very, very basic research idea and a very basic research question, because here, are there other things that affect aggression? Absolutely. But here, you're limiting yourself by saying, I only want to look at the effect of gender on aggression. Well, what about something like provocation? If a person is provoked or not provoked, maybe that might affect aggression. And then if we combine gender and provocation, how does that affect aggression? So here, when you're provoked and you're a male, how does that change your aggression score in comparison to when you're a male and not provoked? Or when you're female and provoked versus when you're female and not provoked? So here you now start combining independent variables, and it starts providing you with a clear picture of what's supposed to actually be happening in terms of behavior. Now, in an ideal world, what we really want to be looking at statistically and research-wise is we really want to be looking at what's called multi-factor designs. So in other words, I want to look at two or more independent variables. So why is it that I want to look at two or more independent variables? Because again, now I can really start combining these puzzle pieces together and start creating a clear picture as to how it is that they together affect my independent variable, or my dependent variable in this particular case. So in other words, rather than just having gender and how that affects aggression, now I may have something like gender, and I may have something like provocation, and how both of these affect aggression. Because together, they're going to create a different effect rather than just examining one or examining the other. So now combining them together are ultimately going to create a better interpretation of how aggression works, rather than just saying, well, if you're male, you're more aggressive than female. Because more than likely someone's going to say, well, what about in the case where you're provoked and you're a female? Does that mean that you're not going to be aggressive? Oh, well, I don't know. I didn't look at that question, or I didn't look at that particular part of the puzzle piece. Well, now you need to go and find that puzzle piece and now do a brand new research study. So you could have potentially been doing multiple things during one single research study to ultimately get a clearer picture on your dependent variable. Now, whenever it is that we use a multi-factor design, this is where we now begin to introduce the idea of what we call a factorial ANOVA, or a factorial design. So whenever it is that we use the term factorial, factorial for us in statistics terms and in research methods terms means that you're dealing with two or more independent variables. How many more? I don't know. It can be 5, 6, 7, 8. It doesn't really matter as long as it's just two or more independent variables. And that's the key with a factorial design, that we have to have two or more independent variables. And that's key. Now here, you'll notice that I'm keeping separate the idea of having two or more groups. So here, I'm no longer discussing this issue of, well, I need 3 groups, or I need 4 groups, or I need 5 groups. That doesn't matter here anymore, because all that really matters is that I have independent variables that are greater than 2. So 2 or more independent variables in this particular case. So here, it doesn't matter if my independent variable of gender only has 2 groups, and my independent variable of provocation only has 2 groups, provoked and not provoked. That doesn't matter, because I'm still going to use, in this particular case, an ANOVA to look at my results, because I'm dealing with more than 2 independent variables. That's the key of a factorial design. Now, what is it that a factorial design is going to allow you to do? A factorial design is going to allow you to examine each independent variable's effect on the dependent variable, and we're going to call these main effects. So this is a new term that I'm now introducing for you. This term of main effect ultimately indicates the effect of an IV on a DV. That's what a main effect is defined as, the effect of an IV on a DV. Now you'll notice here the words that I'm using, the effect of an IV, one single independent variable on the dependent variable. So that's what a multi-factor design is going to allow you to do. It's going to allow you to examine each independent variable's effect on aggression. just as with a single factor design, that I could only examine one independent variable's effect on my dependent variable, multi-factor designs are now doing the same. So here it's giving you this ability to do the following. A factorial design is allowing you to say, how does this puzzle piece affect the entire picture? This one puzzle piece alone. Okay, so how does the puzzle piece of gender alone affect aggression? How does the puzzle piece of provocation affect aggression alone? Okay, it's allowing you to do that. We're going to call that a main effect. So when we think about what a single factor design can provide us, single factor designs can only allow us to examine main effects. Okay, that's the only thing that a single factor design can allow us to do. Why? Because it's only one independent variable. Now, factorial designs are going to allow you to examine the main effect of each independent variable, again, of each IV. So it's going to allow you to examine the effect of gender alone and the effect of provocation alone. But now the good thing of a multi-factor or factorial design is that it's going to allow you to also examine what we call the interaction. And this is really what we really want to look at. This is the good stuff if you really want to think about that. The good stuff here in terms of this interaction is really the combination of independent variables. So in other words, we can assess or we can examine the effect of gender on aggression. We can assess the effect of provocation on aggression. But we can now assess the combination of gender and provocation together on aggression. So here, imagine it as putting two puzzle pieces together and now seeing the picture clearer rather than just having two separate puzzle pieces. So I have the puzzle piece of gender and I have the puzzle piece of provocation. They're two separate puzzle pieces. I can view gender puzzle piece alone and see how it affects the clearer picture of aggression. I can view the puzzle piece of provocation and how it affects aggression's picture. But if I put those two puzzle pieces together, I'm going to get a clearer picture of aggression. And that's ultimately what a factorial design is going to allow you to do. That it's going to allow you to combine these independent variables and identify if it's having an effect on your dependent variable, and it's going to give you a clearer picture of what it looks like. And that's really the key. That's really what we want to look for here. So let's look at this idea of the interaction a little bit more closely. With an interaction occurs whenever it is that we have the effect of one independent variable on a dependent variable at different levels of another independent variable. All right, that's very, very important for us. So it's the effect of an IV on a DV at different levels of another IV. So again, an interaction is going to be defined as the effect of an IV on a DV at different levels of another IV. That's the way we're going to define an interaction. The effect of an IV on a DV at different levels of another IV. So in other words, put it in terms of a context of what we're working with in terms of our example. The effect of gender on aggression at different groups or different levels of provocation. Okay? So in other words, I'm going to compare men and women on their aggression levels when they're either provoked or not provoked. Put it in something that you use in a frequent basis. Studying habits. So imagine you studied 8 hours versus somebody who studied 6 hours. Your studying habits on exam performance for different classes. Okay? So in other words, when you study 8 hours and you take an exam, but you're taking a psych exam, what's your grade on the exam? If you study 4 hours and you take you get an exam score, but you're taking a physics exam, now what's that exam score going to look like? So in other words, here we're saying, look, this puzzle piece affects the dependent variable like this, so this puzzle piece affects the picture like this, but when we add in this other puzzle piece, it changes the view around and it explains it a little bit better, or it doesn't explain it at all. That is a potential factor. So in other words, that puzzle piece may not even fit in there, and it may go somewhere else in the puzzle. Okay, and that's very, very important for us as well. So here again, let's think of this situation here that I've been kind of talking about, the effects of provocation on aggression. In other words, when you're provoked or not provoked, how does that affect your aggression levels? So here, if we think of another variable or factor that may affect aggression, we may think of something like gender, right? That's a very, very common thing for us to think about in the research literature for psychology, that we say, look, there seems to be a lot of gender differences associated with aggression levels. Men tend to have more testosterone than women. That may potentially contribute to aggression levels. Maybe men as being machista, or having this kind of attitude that we're always supposed to be kind of aggressive and overbearing on people. That may potentially then contribute to aggression levels. So here, there could be a lot of different factors of why there may be gender differences, but here we want to examine, well, when you're provoked versus when you're not provoked, what does that look like on your aggression level? And then what happens when we look at men versus women? So here, that may now change around the picture of aggression level for provocation, okay? So here, we may make a prediction like the following. Provocation is going to increase aggression more when the participants are male than when they are female. So here, that's the kind of argument that we're going to make here, right? Or that's the prediction that we're going to make, that we're going to say, look, when your provocation is going to increase aggression, so when you're provoked, that's going to increase aggression more when you're male than when you're female. So you'll now notice here that we see that there's kind of this interaction, a combination of independent variables effect on the dependent variable, because that's what we're assuming here. So in other words, when you're provoked versus when you're not provoked, what is your aggression going to look like? And we have to also consider if you're male and female. And that's a very necessary issue here that we have to look at. Now remember, since this is a factorial design, we can also look at each variable's effect on my dependent variable. So in other words, we can look at the effect of provocation alone on aggression, and I can also look at the effect of gender on aggression alone, looking at those separate puzzle pieces. But here, in an ideal world, I really want to look at the combination, because the combination, the interaction, is really going to set up the situation of it depends. So in other words, when people go out there and they say, oh, well, why are men more aggressive than women? We may say something like, well, it depends. And people are going to say, well, what does it depend on? Well, it may depend on these other factors. That's ultimately what we're trying to say. Or if we find a situation where a female is more aggressive than a male, and somebody says, oh, well, why is it that females are more aggressive than males? And we may say, well, it depends because of this situation. So in other words, they could have potentially been provoked, and thus they became more aggressive than a male who was provoked. So in those situations, we're now really looking at the it depends situation. Now here, a key way of trying to understand an interaction is put an interaction in terms of the following sentence, okay? So remember when I told you all at the beginning of the semester, and I've kind of reiterated this idea of the effect, so the effect of the IV on the DV. Remember we would always say that? We'd always use that, and I would always say, oh, the effect of the IV on the DV, and I would say the IV always comes first. This definition here, or this sentence structure that I've always given you since the beginning of the semester, this is really in reference to a main effect. This is a main effect. So if you read it very closely here, you'll notice that that's exactly what a main effect's definition is. It's the effect of one independent variable on the dependent variable. So again, the effect of the IV on the DV, that's the sentence for a main effect. Because again, look back on your definition that we had here on the previous screen. Our definition was exactly that. Oops. So the examination of one IV's effect on the DV, that's what a main effect is, the effect of an IV on a DV. So then when we look at an interaction and we say an interaction is the effect of an IV on a DV at different levels of another IV, all that we've done is we've just added to that sentence. So again, the effect of the IV on the DV at different levels or groups, if you want, of other IV. And here, I'm going to underline again the key. So IV, so this would be IV number one, the DV, and then the second independent variable. So that's ultimately what we're talking about here, that we're saying to ourselves, all that we really have to do is we have to put in and plug in our independent variables and our dependent variable into the sentence. So again, when we looked at gender and provocation, we're just going to plug in our independent variables. So the effect of gender on aggression at different levels of provocation, or the effect of provocation on aggression at different levels of gender. So here, it doesn't really matter which one you put first and which one you put second. All that really matters is that you're combining them together. So when we think about an interaction, it doesn't matter which one comes first. So it doesn't matter if you say gender on aggression and then provocation, or if you say provocation on aggression and then gender. It doesn't really matter, because here a factorial design is assuming that you've already combined them together. Now, if you guys have noticed, I haven't introduced any formulas to you guys at all. And I'm really not going to introduce a formula for you. I'm going to show you numbers, and I'm going to show you how it is that we use those numbers to identify if there are patterns that indicate an interaction or not. But here in reality, I'm not going to show you a formula for how to do this. Your textbook discusses formulas for how to do it. I wouldn't recommend following along with that at this point, because that is for another course. That is for an intermediate stats class, or even an advanced statistics class, or even a graduate level statistics class, that you would really get into those kind of different issues. And when I teach graduate level courses and advanced statistics courses, I always get into the math associated with those, but for our purposes here, we're not going to get into the math of that. So here, as long as you guys understand the conceptual ideas associated with main effects and interactions, you guys are good. Okay? So here again, what's a single factor design going to give you? A single factor design can only give you a main effect. Why can a single factor design not give you an interaction? So again, here, let's look at this. So why can a single factor design not give you an interaction? Well, because I only have one independent variable. I can't combine it with anything else. So I can't combine it with another IV. Multi-factor designs, on the other hand, allow you to examine each independent variable's effect on the dependent variable. In other words, each independent variable's main effect on the dependent variable, but it also allows me to look at the interaction, the effect of the IV on the dV at different levels of the second independent variable, or the combination of the IVs, which is what we call an interaction, right? That's really what we're looking for here. When we combine IVs together, that's the interaction. The interaction is the effect of the IV on a dV at different levels of the other independent variable. All right, so again, you can use those sentences to kind of keep yourselves kind of straight as to what it is that we're talking about. My recommendation, always put them at the top of the page whenever it is that you're going to do any work associated with main effects and interactions, because it's very important to use those sentences as good foundations and frameworks for understanding their use. All right, so when we now look at interactions and main effects, and we look at factorial designs, one of the major issues here that we have to think about is how many potential results can we have by doing a factorial design or using a factorial ANOVA. So here, whenever it is that I use the term effects, and I mentioned this at the beginning of the semester, but here I'll reiterate it at this point again, the term effects for us in research and in statistics really means results, okay? So here, if you want to use the term results rather than effects, you absolutely can. So here the question now becomes, how many results do we have for my particular design, for my particular statistical analysis? So how many, how many results can I potentially look at? So if I have gender on aggression, provocation on aggression, how many main effects can I have? How many interactions can I have? Which is the question that we really have to think about. So again, remember, whenever it is that we're now thinking about how many potential results can I be examining here, we first have to think about each main effect. So in other words, since we're dealing with multiple independent variables, again, we have to assume that each independent variable has an effect on my dV, okay, individually. So in other words, each puzzle piece has an effect on the puzzle, okay? Think of it like that. So each puzzle piece contributes its own image to the entire puzzle, okay? So it's contributing its own result to the puzzle, which is essentially what I'm saying here. Then we also look at the combinations of independent variables. How many possible combinations can I make? So again, if I have something like provocation and gender, well then here at this point now, I want to combine those independent variables together to see their effect. Now here, think back to what I mentioned at the beginning of this lecture, that I said there's multiple factors that may potentially contribute to the effect on the dependent variable, not just two factors. So here, we're not limited to just looking at two independent variables because the factorial design assumes two or more. How many more? It doesn't really matter, but I can look at a ton of different independent variables and their effect on the dependent variable. So in other words, I can look at many different puzzle pieces, more than just two, and how they affect the dependent variable and how they affect the puzzle. So here, when we add in, for instance, a third independent variable to the mix, here you combine it as well. So you combine it with all the other independent variables as well. So here you can combine gender and a third one, provocation and the third one, and then combine gender, provocation, and the third one together. Because here now we have to assume that potentially we may have something like provocation, gender, and where you're from, the region where you're from, potentially affecting something like your regression level. Now, typical standard practice for us, statistically speaking, we always conduct what's called the full factorial analysis. What does the full factorial mean for us? The full factorial means the following. We are going to examine all possible main effects and all possible interactions. This is the standard practice that we use in psychological research. So in other words, just because you don't care about the main effect, or just because you don't care about the interaction, doesn't mean you shouldn't look at it. So in other words, imagine like buying a puzzle, okay? And then sticking your hand in the puzzle box and pulling out one single piece of the puzzle and then putting it on the table and saying, I'm done. Well, no, right? That's really not fair, because you have all these other puzzle pieces that existed in the box. So why don't you go ahead and take out a couple of more puzzle pieces, put them all together, and see how now the image changes, how that entire puzzle is beginning now to take shape. The same thing happens for us whenever it is that we do research studies. Whenever it is that we collect data, we just don't bring participants into a research study and we say, okay, what's your gender? Male. What's your regression level? A 5. Okay, you can go now. No, I mean, that would be a waste of a participant. But rather, what do? We bring in a participant and we ask them about their gender. We ask them about being provoked or not being provoked. We ask them about where they're from. So are you rural? Are you urban? What's your age? What's your ethnicity? We ask them all these different questions related to who it is that they are, and we collect as much data as we can. So that way, we can gather as many of those puzzle pieces, because we realize that something that is psychological in its nature is not simple. It is complex. So as you guys have probably noticed throughout your short careers in psychology up to this point, psychological principles are complex. They're not easy to understand. I really wish, to be honest with you, I really wish psychological principles were easy to understand and only one independent variable affected the dependent variable. I wish that would happen. That would make everyone's job so much easier. But it's not. Our jobs are really complicated. So for instance, I do language research. One of the things that I have to examine when I think about language research is I have to think about, when did you learn your languages? Did you learn them simultaneously? Did you learn them at separate points in time? So did you learn one language when you were younger and one language when you were older? How competent are you in all the languages? We have to assess a bunch of different factors just to understand how well they can perform on a language translation task. So here you would assume, oh, that should be pretty simple. We'll just ask them, when they learn their languages, or ask them if they're monolingual or bilingual. And the answer is no. The issue is much more complex than it is. So here we really have to think about all these potential factors and how they may affect my dependent variable. So again, assessing all these different components, assessing all the different puzzle pieces individually, and then assessing them combined together is a good standard practice for us to use, because it really gives us a clear picture and we don't have to waste time doing another research study, collecting now more data and having more participants. If I can collect all the necessary data that I think is important for the puzzle all at one time within 30 minutes or within 45 minutes with one participant, I'm going to do it. Because then I can have all the puzzle pieces already at my disposal and I can work on them at that appropriate time. And I don't have to worry about like, oh, well, I didn't think about this one. Now let me go and do another research study and spend a couple of months doing that, collecting that data. Well, no, here it's much more efficient for us just to go ahead and do everything as best as we can and as quickly as we can as well. Now, whenever it is that we're assessing the number of results or effects, again, in a research design, again, we have to think about main effects and we have to think about interactions. So here, take for example the following. Let's assume that my independent variables are gender, provocation, and region. Okay, those are my 3 independent variables. Now remember, we're going to look at main effects and we're going to look at interactions. So again, at the top of your page, if you want, in terms for your notes, write the effect of the IV on the DV. Okay, so that's in reference to main effects. So the effect of the IV on the DV. And now underneath that, write the effect of the IV on the DV at different levels or different groups of the other IV. So here, use those sentences to guide you here through this explanation here. Now remember, I have 3 separate independent variables: gender, provocation, and region. Those are my 3 independent variables. So here now let's look at the main effects. So again, using that sentence, the effect of the IV on the DV, let's now plug in each independent variable into that slot. Now here you'll notice, well, what's my DV? It doesn't matter what your DV is at this point. All I care about is the independent variables. That's what I really am looking at here, because again, that's the issue of factorial. So here, don't worry about the DV. If you want, the DV is aggression. But here, more importantly, I want the IV. So plug into that sentence each independent variable. So you should have, in terms of main effects, 3 separate sentences. The first one is the effect of gender on my DV. Next, the effect of provocation on my DV. And last, the effect of region on my DV. Now, why do I have 3 separate ones? Because each one of these is its own puzzle piece. So I have gender as its own independent variable, provocation as its own independent variable, and region as its own independent variable. Remember, a main effect is the effect of the IV on the DV. So the effect of one independent variable on the dependent variable. So I plug into where the IV slot is, each IV separately. So one sentence for one IV, the next sentence for the next IV, and the next sentence for the next independent variable. Now, let's look at interactions. Remember, combinations of my independent variables. Now here, be very careful because now I have 3 independent variables. So here I had to think of all possible combinations, okay? So now let's begin to combine. So again, the first combination here that I want to make is I want to make gender and provocation. So the effect of gender and provocation on aggression. Next, gender and region. I'm going to combine those 2 together and I'm going to exclude provocation. So now I'm looking at the effect of gender and region on aggression. Next, provocation and region. I'm now combining those independent variables together. In this particular case now, I've excluded gender and I'm now looking at the effect of provocation and region on aggression. Now the question is, are we done? And the answer is, no, we're not done. And why? Because remember, interactions don't tell you can only combine 2 independent variables. It says all possible combinations. So now I have 3 independent variables: gender, provocation, and region. So now think of the following situation. You're male, you're provoked, and you're rural. How is that going to affect your regression score? Versus you being male, provoked, and urban. How is that going to affect your regression score? So here now we see that when we start combining now more and more and more independent variables, this starts getting more and more complex. Now, just to use some basic terminology here and use the consistent terminology that we use in your textbook and also here as I discuss our lecture, whenever it is that we talk about main effects, again, these are all single factors. Okay? Because remember, I'm only dealing with one IV in each one of these cases. Single factor, single factor, single factor. Here now, I'm dealing with multi-factor for each one of these, right? Because I'm dealing with multiple independent variables. Now, very important, remember, I've already introduced this idea of what we call wayness. I introduced it in my previous lecture associated with ANOVA. Wayness referred to the number of IVs. So remember when I used the term one way, and I said, oh, that references one independent variable. Here, each one of these single factors is essentially a one way. So the one way for gender, one way for provocation, one way for region. Okay? Because it's one independent variable's effect on my dependent variable. Now for multi-factor designs, here I'm now dealing with different numbers of independent variables. So here, for instance, I'm dealing with two IVs, and two IVs. So rather than saying a one way, I'm now going to say it's a two way. So in other words, this one is a two-way factorial design. Down here, I'm dealing with three independent variables, so three IVs. So here, I'm going to again substitute 2 for 3, and I'm going to say it's a three-way. So this is my three-way interaction. So here, I'm going to say this is a two-way interaction because, again, it's in reference interactions because I'm combining. Here, we wouldn't say that this is a one-way interaction because an interaction assumes that you're combining independent variables. So here, we just say this is a one-way. Here, we're now saying two-way interactions. Okay, so very important to use that terminology appropriately here. Now, whenever it is that we actually encounter situations where we're going to end up using factorial designs come in different forms, okay? And it's very important for us to also discuss these different types or these different forms of factorial designs. Now, whenever it is that we think about factorial designs, we again have to think about the involvement of the independent variables. So again, how many IVs are we dealing with factorial designs? Minimum of 2, or we can have more. So I have to have 2 IVs or more, okay? 2 independent variables or more. So I'm dealing with more than 1 IV in my situation. Now, there are 3 types of research designs that correspond to the use of factorial designs, okay? So in other words, when I have a research study and a statistical analysis that's going to be using 2 or more independent variables and their effect on the DV, I have to think about what do the independent variables look like? How are participants participating per IV? That's a key question there. So again, I'll say that question again. How are participants participating per IV? Now, if you're probably thinking to yourself, I have no idea what you just talked about. What do you mean? Ultimately, I mean the following information. We're now going to introduce our terms that we've already been introduced to in our previous lectures many times, the issue of a between and the issue of a within design. But now I'm going to add in one more, and we're going to call this a mixed design. Okay? So between, within, and then we're also going to have what's called a mixed. So between, within, and mixed. So let's begin with between first. So if you remember from our previous discussions associated with between groups research designs, we talked about this with our independent samples t-test. We also talked about it with our ANOVA, that we had our one-way ANOVA, in that we had independent samples. So in other words, we had groups that were mutually exclusive from each other. We had between groups research designs. Now, how does this now apply to a factorial design? Well, I have to look at each independent variable. So what a between groups factorial design means is it means that all my independent variables are of the between groups type. Okay? All of my IVs are of the between groups type. What does this mean for me? It means that my first independent variable requires participants to only be in one group of that independent variable. My second independent variable requires that participants can only be in one group of that second independent variable. So if you're probably thinking to yourself now, okay, I'm totally confused. What is potentially happening here? Okay, let's go back to our previous discussions of between groups designs. We talked about groups being mutually exclusive. Now here, remember, the idea of a between groups design was in reference to the independent variable, that we would say something like gender. Gender has mutually exclusive groups, so you have a between groups research design. So in other words, participants can only be in one group of gender. In our case, we're looking at gender. So gender, in this particular case, is of the between groups type. In other words, we're requiring participants to only be in one group of that particular independent variable. Okay? My second independent variable has to have that same requirement. Now, if both independent variables here have that same requirement, the participants can only be in one group of each independent variable, then I'm going to classify it as a between groups factorial design. So let's take, for example, the following. Let's look at the effect of gender and major on math efficacy. So here, again, it doesn't really matter what my dependent variable is. What I'm really concerned with here is my independent variables. Now, again, using the sentence, the effect of the IV on the DV, we're still going to now just plug in everything there. So now here, all that I'm saying is the effect of an IV and another IV on my DV, okay? Because I have two independent variables in this particular case. Now here, we're going to assume the following, and this has to be the assumption, that here, gender, you can only be in male and only be in female. You can't be in both. Now, in this particular case, now you may be telling yourself, well, you can have a double major. Yes, you can. But what if I don't allow that? What if I don't allow you to be classified as a double major? What if when you come in, I say, okay, what major are you? And you tell me, well, I'm a double major. No. And I tell you, you can only be math, you can only be physics, you can only be psychology. You have to pick one of them. You can't be in multiple groups. Then at that point, I'm also using major in that particular case to be a between groups type. So in other words, I'm forcing you to pick math, physics, or psych. Okay? You can only be in one of those. You can't be in multiple ones. Now, if you want to have people that can be in multiple majors, then it's not going to satisfy the between groups criteria. Because remember, with the between groups criteria, it's expecting here that participants can only be in one group of that particular independent variable. Now, if you notice here, my gender independent variable only has two groups. My major variable, I selected three groups. If I only wanted to have two groups, I can have two groups. It doesn't really matter for me. But here, I can have two groups, three groups, three groups, two groups, three groups, four groups, five groups. It doesn't really matter because all I really care about is the number of IVs that I'm working with. And here, I'm dealing with two independent variables. Okay, so that's our first type of factorial design. The between groups type requires all my independent variables to be of the between groups type. So in other words, Matt comes in, he's a male and he's a math major. Okay, and that's it. Matt can't be female also and a math major. He can only be male and a math major. Susie comes in. She's female. She's a math major. Perfect. Erica comes in. She's female. She's physics. Mike comes in. He's male. He's psychology. So again here, they are in mutually exclusive groups in each one of the independent variables. So again here, since I'm working with multiple puzzle pieces, I have to make sure that they fit into one of the categories for one of the puzzle pieces and they fit into at least one of the categories for that second puzzle piece, but only one of those categories. They can't be in multiple categories. Our second type of factorial design is the within groups type. What does a within groups type factorial mean? Well, let's look back here at what the issue of within refers to. The issue of a within groups design, we talked about it when we talked about a related samples t-test and also when we talked about a repeated samples ANOVA. That here you're using the same participants across all the groups. They have to be in all the levels, they have to be in all the groups, they have to be in all the conditions. So in other words, something like gender wouldn't work because participants can't be in all the genders. They can only be in one gender if that's what you stipulated. So now here with the within groups factorial design, we have the requirement that all our independent variables are of the within groups type. So in other words, all of my independent variables require my participants to be in all groups of each of the independent variables. Okay, so that becomes a little bit difficult to do. So here, let's think of an example. The effects of day and time on fatigue. So day and time are my IVs, fatigue being my DV. So here what we're going to do is we're going to take Susie, and Susie's going to be tested Monday, Tuesday, Wednesday, Thursday, and Friday. And she's going to be measured at noon and at 5 p.m. on Monday, Tuesday, Wednesday, Thursday, and Friday. So again, Susie now is in all the groups of day. She's in Monday, Tuesday, Wednesday, Thursday, Friday. So I have 5 groups for day. She's in all of my groups, so she's tested every single day. And time, she's tested 2 times during the day. She's tested at noon and at 5 p.m. Okay? Now, if Susie comes in and she is tested Monday, Tuesday, Wednesday, Thursday, Friday, but only at noon, and she's not in the 5 o'clock group, then we don't have a within groups type. Okay? Because in that case, my second independent variable of time would be between groups type, because you're not allowing her to be in all the times. You're only allowing her to be in one of the times. And here what I want to do is I want them to be in all of the days and all of the times. Okay, that's what I want to do here. So again, I'm going to test her Monday, Tuesday, Wednesday, Thursday, Friday at noon and at 5, because those are my 2 groups for time. Eric comes in. Eric is tested Monday, Tuesday, Wednesday, Thursday, Friday, noon, and 5. So again, everyone is in all the groups of day and all the groups of time. Now, is there a situation where you may say, okay, well, is there a situation where you may have something like gender and day? So in other words, you want to test people Monday, Tuesday, Wednesday, Thursday, Friday on fatigue, but you also want to look at differences between males and females. So I want them to be tested all week, but they can only be in one group of gender. And the answer is yes. Here, that's where we introduce our third type of design. This is our third type of factorial design that we call a mixed factorial design. What is a mixed factorial design? A mixed factorial design essentially is going to be a combination of between and within groups types, within and between groups types independent variables. In other words, at least one IV has to be between groups, at least one IV has to be between groups. One within, one between. One within, one between. Now, what happens if you have 3 IVs? Again, minimum, one has to be between, one has to be within. Okay? So you could have 2 within, 1 between, it's still mixed. You could have 2 between, 1 within, still mixed. It doesn't really matter. As long as 1 is within and 1 is between, you now have a mixed design. So in other words, one independent variable requires participants to be in all the groups, and one IV requires participants to only be in one group. So now think of something like the effects of gender and day on engagement in early classes. So in other words, you can only be in the male or the female group. So this one is between. Okay, so gender is between because it requires you to only be in one group. Those are mutually exclusive groups. But day, now we're allowing you to be in there Monday, Tuesday, Wednesday, Thursday, Friday. So in other words, Matt comes in, he's male, he's tested Monday, Tuesday, Wednesday, Thursday, Friday. But he's only in the male group. He's not in the female group. So here, since gender is not within, I'm now going to classify it as mixed. All right, so those are our 3 types of research designs that we're dealing with. All right, so here I've set up an example for us to look at this idea of how it is that we actually use factorial designs in a research situation in terms of collecting of data and trying to analyze that data. Now, I promised you that I was not going to show you any formulas, and I'm not going to show you any formulas. All that I'm going to do for you here is I'm just going to show you techniques that we actually use to be able to understand patterns of results and for us to be able to identify if we have potential main effects that exist and also potential interactions that may exist also. So one of the things that we have to consider, and again, going back to some of our previous slides here, if we look at this idea of a main effect, the effect of an IV on a DV. So one single IV on the DV, I have to try to understand and I have to try to believe for myself, well, am I looking at differences between the groups on my dependent variable? Are there significant differences? Okay, that's really the question that I want to ask about each one of my independent variables. And then what I want to ask is I want to see for myself, are there any combination effects? So when I combine independent variables together, what does their result look like for my dependent variable? Which is essentially what I'm really trying to get at here in terms of our examples. So I've set up our examples here, and again, just to make sure that we keep everything consistent, using the example of gender and provocation, and I have my aggression level as my dependent variable out of a score out of 10. So let's say, for instance, that we were going to measure males who got provoked on aggression. So out of 10, what would you think a male who got provoked might be aggressive out? So if, let's say, aggressive acts out of 10, let's say a 9, right, as an average. So males who are provoked in terms of aggression levels. Now, what about females who are provoked? Well, let's say females that are provoked, aggression levels out of 10, let's say a value of a 6. Males not provoked, let's say a value of a 6. And females who are not provoked, a value of a 3. Okay, so here are my numbers that I'm going to be using for our particular example. If you want, there you go. I'll make these numbers just a little bit larger just so that way we can see them a little more clearly. Okay, so this number here that we have a value of a 9 represents all male participants that we have in our study who've been provoked, and that's their average aggression level. Here is the average aggression level for women who have been provoked. Here is my average aggression level for men who have not been provoked on aggression level, and here's the average of females who have not been provoked on aggression levels. Okay, now whenever it is that we want to look at these ideas of trying to understand how we can actually interpret our data, we have to assess a couple of different issues. So the things that we want to assess here are the following. Number one is I want to assess the main effect. Okay, so I want to assess the effect of the IV on the DV. Now here, again, I'm working with two independent variables, and here I'm just using two for simplicity's sake. I haven't included a region because it would just make things a little bit more complex for us, so I want to keep things a little bit simpler in terms of our conversation of interactions and main effects. So when we look at this idea of a main effect, the effect of the IV on the DV, again, I'm working with two independent variables. So each independent variable has its own effect on my dependent variable. So gender has its own effect and provocation has its own effect. Now, if you look at the data that's on here on this table, you'll notice here that there's something very interesting. You'll notice that I have two numbers for men and I have two numbers for women. I also have two numbers for people who have been provoked, and I have two numbers for people who have not been provoked. Now you're probably thinking to yourself here, well, hey, those numbers don't really seem fair. Well, if I want to know the effect of gender on aggression level, and I want to know the effect of provocation on aggression level, I cannot use these numbers that are here. Now, if you're asking yourself, well, why can't I use those numbers that are there? Well, you can't use these numbers directly, but you can use them indirectly. Now, what does that mean? Well, let's say, for instance, I needed to know how all male participants in my study, irrelevant if they were provoked or not provoked, right? So it doesn't matter if they were provoked or not provoked. I need to know how all male participants did in terms of their aggression levels. I don't have one single number here that tells me all male participants. Again, this value of a 9 represents men who have been provoked. This value here represents males who have not been provoked. So here I don't have a number that just represents men alone. So here what I have to do is I have to create my own average that represents all male participants in terms of their aggression levels, not including the issue of provocation. So in other words, I want to eliminate the issue of provocation in terms of this number and only use the male participants' average for aggression as a whole, not including provocation. Now you're probably asking yourself, well, how do you do that? Well, I have two numbers here that represent men. Those two numbers there, if I add 9 plus 6 and divide by 2 in this particular case, that's going to give me a value of a 7.5. Okay? So here, this value of a 7.5 is my average for all men who participated in my study on their regression level. So in other words, we're going to assume here that this number of 7.5 is the effect of males on aggression level. So in other words, this is males' aggression level as a whole. It doesn't matter if they're provoked or not provoked. Now you're probably asking yourself, well, but technically they were provoked and they weren't provoked. Yes, but those two numbers essentially cancel out the idea that they were provoked and not provoked, because each one of them is bringing in their own manipulation and their own control, so thus they're carrying their own weight. So it doesn't matter that this number here was provoked and this number here was not provoked, because this number here cancels that idea out, saying we're going to meet right in the middle and assume that if it's just their aggression level, it doesn't matter what we're doing to them, this is what we would assume their aggression level would be. So here, that's the closest number that we can get to male performance, not including the other independent variable. Now we need to do the same for women, because again, this number of a 6 does not represent all women. This number of a 3 does not represent all women who participated, but rather both of them together do. So if we add them up, 9 divided by 2 is now going to give me an average of a 4.5. Okay, so that's my average of a 4.5. So I'll just make this number just a little bit larger. There we go. So now what I want to do is I want to look at the main effect of gender on aggression. Okay? Because remember, if I'm looking on that list of the number of possible effects that I want to examine, remember when I looked at all the main effects and all the interactions, the first main effect that I wanted to look at was the main effect of gender. So here I want to see, is there a difference between men and women on aggression levels? So in other words, what I want to do is I want to compare those two numbers together right here, and I want to identify if there's a significant difference between them. So what I want to now do is I want to do a test that's going to compare those two values in terms if they are significantly different from each other. Now this semester we learned about a statistical test that compares two values, two averages from samples from mutually exclusive groups. What is that statistical test? So I'm comparing two groups that are mutually exclusive on one common dependent variable. What do we call that? And here, that should be our independent samples t-test. So that's the statistical test I would use in this particular case. Why would I use an independent samples t-test in this particular case? Because I'm only comparing two groups in this particular case. Okay? That's why I'm doing that in this particular instance. Now, if you're wondering here why I have this term marginal means, why is it that I have that term here? I use this term here, marginal means, because this is what we call these averages. We call these averages that exist in the margin of this table the marginal means. Why? Well, because they are the new averages that we create that are created based on all the other values that existed within my table. Okay? Now, these values here we're going to call marginal means because these are the averages that exist out in the margins of my table. Now, if you're wondering, well, then what are these values called here, the ones that are inside of the table? We actually call these cell means. And the reason we call these cell means is because these are the values that exist within the cells of my table. And I'm sorry guys, this isn't a joke or anything, but this is just the way we created these names. I think it was a really, really late night or something, and we were running out of ideas of what to call these numbers. And we just said, man, just call them marginal means and call them cell means. Why marginal means? Well, because they're the ones that exist in the margins of the table. And why cell means? Because they're the averages that exist in the cells of the table. So I think that's why they ended up calling them cell means and marginal means. So here, these marginal means are the ones that I just created, And marginal means are going to be used to test main effects. Okay? So again, marginal means are going to be used to test main effects. Okay, very important. Why? Because these values here, essentially think of them as being unbiased or not polluted by the other independent variable. So here, these numbers here are not polluted by provocation and not provocation. We just assume that it represents all males in terms of their aggression levels. Now, next here, we want to look at the average for females. So in this particular case, I compared these two groups that are mutually exclusive to each other, their averages using an independent samples t-test, because that would be the statistical test that would be appropriate for that kind of statistical analysis for a main effect, the effect of an IV on a DV. In this particular case, because my IV only has two groups. Now, I want to now look at the main effect. So I already looked at the main effect for gender. I now want to look at the main effect for provocation. So now here, I'm going to do the exact same thing, but rather than going across, I want to go up and down here. And why? Because this number of 9 and this number of 6 represents provocation. This number of 6 and this number of 3 represents non-provocation. So here we're going to do the exact same thing that I need to create my marginal mean for provocation. And I'm going to go ahead and do that. So 9 plus 6 is going to be a value of a 15 divided by 2 is also going to be a 7.5 in this particular case. And then also here, this average would be equal to a 4.5. So it just happens to be that these numbers that I created just happen to be the same in both instances for the marginal means. This will not always happen. It's just what happened here in this particular case. So now I have the marginal means for provocation and non-provocation. So in other words, when people are provoked as a whole, independent if they are male or female, their average on terms of aggression is about a 7.5. When people are not provoked, it doesn't matter if they're male or female, their average aggression score is a 4.5. So here we now can compare my two averages of 7.5 and 4.5. This is my test of a main effect for provocation, because these two numbers here represent provoked and not provoked. So main effect for provocation. And if I wanted to use a statistical analysis, again here I'm going to assume that provocation and non-provocation are mutually exclusive groups. So what statistical test have we learned that compares two groups that are mutually exclusive from each other on the same dependent variable? You guessed it, an independent samples t-test in this particular case as well. Now, this would always be the case. And the reason I indicate this for you is because what happens in the case where I would have had three groups, provoked, moderately provoked, and not provoked. If I would have had three groups in that particular case for that independent variable, the test of the main effect for provocation for three groups of provocation would have no longer been an independent samples t-test, but would have been an ANOVA, because I would have had three groups within that independent variable. So you see here, my point is the following. My point is, depending on what my variables look like, I then decide what statistical test to use. I didn't walk into any of these examples, guys, saying, oh, I'm going to use a t-test or I'm going to use an ANOVA. I'm now deciding what to use because of what my variables look like. So in this particular case, this variable of gender has two groups. This variable of provocation has two groups as well. Both independent variables assume that groups are mutually exclusive from each other. So thus, I'm going to use independent samples t-test to evaluate main effects in both of those cases. Now, if I had three groups for any of these variables, then I would no longer use an independent samples t-test, but I would have to use a ANOVA, because that would be the more appropriate statistical test to use since I have three or more groups in that specific situation. All right, so now that we've talked about how to use our marginal means for the evaluation of main effects, now we want to look at the aspect of an interaction. How do I test the interaction? So I've already discussed here, how do I test for main effects? How do I test again for the main effects? I test for the main effects using my marginal means. Okay, that's how I'm going to test for a main effect, using my marginal means. Now, how am I going to test for the interaction, the combination of gender and provocation? How am I going to test for this? For gender and provocation, the combination of my independent variables, rather than using my marginal means, I'm going to use my cell means. So in other words, rather than looking on the margins of my table, I now want to concentrate here on the middle portion of my table, looking at the numbers that exist within the cells. Because if you notice now, these numbers here represent the combinations of independent variables. This value of a 9 represents the combination of the gender and provocation variable, so males who are provoked. This one here represents males who are not provoked, females who are provoked, and females who are not provoked. So here we start now noticing that within this table, we start now seeing the combination of the independent variables already manifesting themselves, that they're already existing here. So what we now want to do is we want to use the cell means for the examinations of interactions. So cell means are going to be used to test the interaction. Okay, now how are we going to test the interaction? What we want to do is we want to look at the pattern of my scores. Okay, that's going to be the important part here. So what I'm going to do is I'm going to be switching in between different colors to show you these patterns. Okay, now based on these patterns, we're going to be able to identify if we have an interaction or not. Okay, how are we going to do this? This is the way that this is going to happen. What I'm going to do is I'm going to have to go first. I have to go across. So looking at my numbers going across. For males first, and then also for females. So I have to go across for males and then go across for females. And that's going to be my first pair. Why is that going to be my first pair? Because that's the pair for gender. Then I have to go up and down, looking at the pattern of the numbers going up and down. That's going to be the pattern for the provocation variable, okay? So here, first going across, let's look at the pattern of the arrows going across for the gender variable. So if you look here at the numbers, we look at these numbers and we notice that the numbers go higher to lower in this particular case. So I'm going to draw an arrow pointing in this direction. So we have a number that goes higher to lower in this particular case. Here you'll notice that we also have a number that goes higher to lower. So here I'm going to draw this arrow going in the same direction. Now, the arrows in this particular instance are both pointing to the same direction, that the arrows are pointing to the right in this instance. Now, if both arrows would have been pointing to the left, that would have been okay as well. Now, what would have happened in the case where one arrow would have been pointing to the right and one arrow would have been pointing to the left? That's where it starts getting fun, that we start saying, oh, well, that was interesting. What happened there? Okay, but for now, all I really care about is what direction are the arrows pointing. In this particular case, both arrows are pointing in the same direction. All right, we're good in this particular case. So now, let me just change my pen color in this instance. Change it to green. All right, and now we're going to go up and down. So we have to make arrows going up and down. Look at that pattern. So here you'll notice that we have higher to lower. So I'm going to draw an arrow going down. And we also have higher to lower here. Okay, now this is where the fun begins, that we start talking about an interaction. So how do these cell means test the interaction? Okay, essentially the interaction is tested by looking at the pairs of arrows. So the interaction is tested by looking at the pairs of arrows. So in other words, what I want to do is I want to look at the arrows that are of the same color. So in other words, I want to first look at the green arrows. Are they pointing in the same direction or are they pointing in opposite directions? In this case, they're pointing in the same direction. All right, now let's go to the next pair of arrows, our red arrows. Are they pointing in the same direction or are they pointing in opposite directions? And here, they're pointing in the same direction as well. Now, to identify if an interaction exists, so an interaction, is it present? So in other words, is there an effect of the IV on the DV at different levels of the other IV? So in other words, when I compare men and women on aggression levels, and I also look at provocation, what happens there? Do scores change or do they stay the same? When I compare people who are provoked and not provoked on aggression levels, now looking at men versus women, what happens there? Are the scores changing or are they remaining the same across both groups? That's really what we're looking for here. So if an interaction exists, what would I see? If an interaction were to exist, we would see pairs of arrows that are pointing in the opposite direction. Okay? So I'll say that again. If an interaction were to exist, I would expect pairs of arrows to point in different directions. So in other words, my red arrows, if an interaction were to be present, I would expect one arrow to go to the right, one arrow to go to the left. Okay? Doesn't matter which one goes to the right and which one goes to the left. As long as they're pointing in opposite directions, now I have an interaction. That's how I identify the interaction. Now, if you're thinking to yourself now, okay, I'm pulling out my hair, totally confused. What are you talking about? How is this working? You just have to trust me on this at this point, to be honest with you. Here, that's just the way that we actually do this. Whenever it is that we're testing for an interaction and we're looking at our table of data just as the way that we're looking at here, we literally sit down and we draw our arrows out and we look at them and we say, do our arrows point in the same direction or do they point in opposite directions of each other? In this particular case, I only want to look at arrows that are similar color to each other. The other arrows don't matter. So the green arrows at this point don't matter. I only want to look at the red ones at this particular second here, okay? So in other words, do the arrows point in the same direction? This answer in this particular case is yes. Now I look at the green arrows. Do the green arrows point in the same direction or opposite directions? They also point in the same direction. So since all the arrows point in the same direction, there is no interaction. Okay? So here, since all the arrows point in the same direction, so all the pairs of arrows point in the same direction, so all my red arrows and all my green arrows point in the same direction, there's no interaction. So my red arrows, they both point to the right. My green arrows, they both point down. No interaction. If my green arrows would have both pointed up and my red arrows would have pointed to the right, still no interaction. Why? Because the pairs themselves are all pointing in the same direction. Now, what would have happened in the case where the red arrows are pointing to the right, but the green arrows are pointing in the opposite direction? Then there is an interaction. What happens in the case where the green arrows are pointing in the same direction, but the red arrows are pointing in the opposite directions? Then there's still an interaction. Why? Because now when I look at the pair of colored arrows, they are pointing in opposite directions to each other. Okay? Now, there is another method for us to use to identify if an interaction is existing or not. The way that we're going to do this is actually by drawing out a line graph. And here I'm going to go ahead and do that for us. So here what we're going to do is we're going to draw a line graph and we're going to identify on the x-axis we're going to put one IV. So here I'm going to put gender, for instance. I'm going to say male and female down here. And then I'm going to say my dashed line is going to be provoked. And my solid line is going to be not provoked. And then on my y-axis here, this is going to be my variable of aggression, my average aggression. All right. So here what I want to do now is I want to plot out my data. So just as we did with the other ones that I had different colors, I'm going to try to keep them the same color here just so that way we don't really get too confused on them. But here, if it ends up getting a little bit too messy, I'll end up moving to different colors. So here, all I'm going to do is I'm going to plot out my data. So here, I need to look first at all my data. So what I want to do is I want to plot out my data for my participants. So I want to plot out first for my male participants. So males who were provoked, what was their score? So again, if we go back to our PowerPoint, males who are provoked, they got an average of a 9. Okay, so we're going to say here 0 to 10 on my scale. So males who are provoked, they got a value of a 9. Okay, now males who are not provoked, they got a value of a 6. So we're going to say somewhere about here. Okay. Now females who are provoked, they got a value of a 6. And we have females who are not provoked. They got a value of a 3. Somewhere around there. Okay, so now what I'm going to do, these 2 points right here refer to people who are provoked. So here I'm just going to draw out my dotted line. There we go. As best as I can do. You know what? I really didn't like that. Sorry, guys. There we go. And then here is the people who were not provoked. Oops. Don't want to drag that. Sorry, guys. Okay, to the best of my being able to draw straight abilities. Okay, so now you're looking at this and you're telling yourself, okay, now what? So you drew these lines on a line graph. What's happening now? Okay, using a line graph is actually a very useful technique rather than trying to draw your arrows on a table just as this. So I tell you that this is actually a very common practice for us to do, that we put out our numbers in a table and we draw our pattern of arrows, and then we say, okay, do all the arrows point in the same direction? So do the pairs point in the same direction or do they not? If they do, then there's no there's no interaction. If they don't, then there is an interaction. The other method that we use is by plotting out our data in terms of a line graph, just as we have here. So in our particular case here, what we want to do, and here, let me just get that a little bit closer. There we go. Here what we want to do is we want to look at the lines. So again, the lines represent the pattern of the arrows, to be honest with you. So for an interaction, if an interaction exists, our lines would not be parallel. Okay? If an interaction exists. So our lines would not be parallel. If no interaction, our lines are parallel. So here, what did we find? Well, we found that pretty much our lines are parallel to each other. Again, based on my best drawing ability, right? I wish I could have been drawing a little bit better and a little bit straighter. But here, ultimately, my lines pretty much have the same slope. So here, my lines are equal to each other in terms of their slope, and they're parallel to each other. So in other words, they are not deviated in any capacity. So in other words, I don't have one line going like that and one line going like that. If I would have found this, there would have been an interaction. If I would have found that one line would have been going like that and one line would have been going like this, there still would have been an interaction. Why? Because my lines would have not been parallel. What if I would have found a situation where one line went like that and one line went like that? I still would have found an interaction because, again, my lines are not parallel to each other. So here, if you actually look upon this logic that I'm giving you here, if the lines are parallel to each other, there's no interaction. Here, this confirms it for us because I told you, well, all the arrows point in the same direction. All the pairs point in the same direction. Thus, there's no interaction. All my red arrows point in the same direction. All my green arrows point in the same direction. I told you, no interaction. Here now, there is an interaction. I have arrows that are not parallel to each other. Thus, they are having there is no interaction in this particular case. Now, what happens in the case where we do find that there is an interaction? In the case where we find that there is an interaction, there are different types of interactions that may exist. What are those different types of interactions? There are two types of interactions that may be present in our data. The two types of interactions that we have, and let me skip here forward to, I'll come back to this slide in just 1 second here. So if you guys are like, what happened there? Just don't worry about it. I'll come back to this one in just a minute. If we actually find that our lines are not parallel to each other, we have an interaction, right? So if our lines are not parallel, we have an interaction. So there are two types of interactions that may exist. The first one that we have is what we call an ordinal interaction. And an ordinal interaction is where essentially we have lines that are not parallel to each other. In other words, they have different slopes, but they don't cross, they don't interact with each other, they don't intersect, nothing happens. The only thing that happens between them is that they are not parallel to each other, but they don't touch, they don't cross, nothing. Our second type of interaction is what we call a disordinal interaction. Again, our lines are not parallel, so they have different slopes, but now our group signs or our group differences have reversed their sign at some level at the other IV. Now, if you're asking yourself, okay, now what does that mean? That essentially means, well, did the lines cross or did they not cross? Here, and for us, if our lines are not parallel and the group differences reverse their sign at some level of the other IV, that means that the lines cross. So the two types of interactions that we have, one, they're not parallel, lines don't cross, they don't touch. Second type of interaction, lines are not parallel, but they cross or they touch. So those are your two types of interactions. So here, like I mentioned to you, we have in this particular case, we have an ordinal interaction. Our lines not parallel, but they don't cross. Here, ordinal interaction, lines are not parallel, but they don't cross, they don't touch. Here, we have disordinal. Lines cross and the lines are not parallel to each other. In our particular case here, no interaction. So here, how do we confirm no interaction? Lines are parallel to each other. All right? And again, that confirms from what we found with our arrows that we had in our table. All right? Now, let's go back here to this previous slide here that I wanted to talk to you guys about just a little bit. In terms of a very special type of effect that we find in terms of interactions. Now, simple effects are actually used whenever it is that we want to look at an interaction more closely. Now, what is a simple effect? Now, be very careful here, because the definition that a simple effect uses is very similar to the definition of what an interaction uses. Remember, an interaction is the effect of the IV on the DV at different levels of another IV. A simple effect is the effect of an IV on a DV at only one level of the other IV. So if we look back here at our example associated with gender and provocation on aggression levels, here what we would be looking at is, we would say, what is the effect of gender on aggression at only one level of provocation? So here, again, another recommendation, write down that sentence associated with what a simple effect is. So the sentence is the effect of the IV on the DV at only one level of the other IV. So in other words here, what you would do is you would say the effect of gender on aggression at only one level of provocation. What is that level? Let's say provoked. And then you would redo it again and you would say the effect of gender on aggression on the other level of provocation, which would be not provoked. Okay? Now, whenever it is that we're talking about simple effects come in what we call sets. Now, what are sets of simple effects? Sets of simple effects essentially refer to the following. The second IV is really what it refers to. Now, how do we actually do this? We essentially say the following, and again, using that same sentence, and here I'll write it on our other page here. So for simple effects, we want to create sets, okay? Now the sets, how many sets are you going to work with? The sets depend on the number of IVs that you have. Okay? So in our case, I have two IVs. So I'm going to have two sets in my particular case. Now, set 1 is essentially going to use the following sentence. The effect of IV, and I'm going to say 1, on DV at only one level of IV2. Okay? Now, essentially what I've done here is I've taken this exact sentence that I've given you here, the effect of the IV on a DV at only one level of another IV, and I've just expanded it just a little bit more to become a little bit more detailed. So the effect of the first independent variable on the dependent variable at only one level of the second independent variable. So here what I want to do is I want to do the following, is I want to identify what goes where. Now here, what I want to make sure of is that I want to know what the other level is. So the first set is going to use the first level of the second independent variable. The second simple effect is going to say the effect of IV1 on DV at only second level of IV2. So in other words, in my first simple effect for my first set, I'm going to put in the first level of my second IV in the second part of this sentence. In the second simple effect, I'm going to put in the second level in the second part of the simple effect. So here, if we were going to state these out, we would say the following. The effect of gender on aggression at only provoked. And here I think I misspelled provoke, sorry guys. There we go. At only provoked. So that's my first simple effect. My second simple effect would say, whoops, okay, I don't know what's happening there. There we go. My second one would say, the effect of gender on aggression at only not provoked. So there you go. That would be my first set of simple effects. Now, if you want to follow along here with the table that I've given you, essentially what I'm doing here is I'm doing the following. I am first comparing males and females who are provoked, and then I'm comparing males and females who are not provoked. So this was simple effect number 1 and simple effect number 2 for set 1. So set 1 in both cases. So this was my first simple effect for set 1 and my second simple effect for set 1. So comparing men and women who are provoked. So I'm going to ignore not provoked because all I care about is provoked. So here imagine like a little cover being over not provoked, and all that I can see is being people who are provoked. Then I ignore people who are provoked and compare men and women who are not provoked. But now, since I have a second independent variable of provocation, I now want to look at the comparison of people who were provoked and not provoked, who were only male, and then people who were provoked and not provoked, who were only female. So here now what I want to do is I want to compare these differences between these two groups at only one level of gender. Okay? So here I now need to set my second set of simple effects. And what's my second set of simple effects? So now gender and provocation are going to switch places. Okay? So that's all that's going to happen here. So first, what we're going to do, if my screen stops scrolling, there we go. The effect of provocation on aggression at only male participants. My second one would state the effect of provocation on aggression at only females. And why? Because again, going back to my table, now what I want to do is compare individuals who are provoked and not provoked for only males. And next, I want to look at only females. So that gives me my complete set of simple effects. That here now what I'm doing is I'm going across and I'm going up and down. So if you notice, these were the arrows that I drew. It's the exact same thing here that I've done. All I'm doing now is I'm essentially putting this in a representation where I can say to myself, perfect, this is what it is that we're going to look at in terms of the comparisons of my groups. Now, on our particular case, where we're looking at here, and we wanted to say to ourselves, okay, if I want to identify simple effects, how can I do that using my graphical representation? Using your graphical representation, it's actually quite easy to be able to identify simple effects here. And here very quickly, let me just change colors of my pen, just so that way you guys can notice the differences a little bit more clearly. So what we want to do first is we want to look at the first simple effect. So we want to compare men and women who are provoked, okay? So what I want to do is I want to find the line that compares male scores and female scores for people who were provoked. In our particular case, remember, the dotted line represents provoked, and now you'll notice that this is the point here for males, this is the point for females. So this is my simple effect for comparing males and females who are provoked. So in other words, this was my simple effect number 1 for set 1. So in other words, it compares now the score for males and for females who were provoked. So again, remember those scores were 9 and a 6, if I'm not mistaken, for people who were provoked, male and female. Here, again, male and female, my averages were 9 and 6 for people who were provoked. So there we go. So there's that simple effect. My second simple effect, comparing people who are male and females who were not provoked. There we go. Male, female values, people who were not provoked. So this is my simple effect, number 2 for set 1. Okay? So now, again, I'm going to change colors. We're going to go with blue. I want to do my other set of simple effects because remember, my next set of simple effects was looking at the difference between people who were provoked and not provoked who were male, people who were provoked and not provoked who were female. So remember, that number there represents people who were provoked, people who were not provoked, who were male. So in other words, those numbers right here are going to be my simple effect number 1 for set 2. And next, I want to look at the differences between people who were provoked and not provoked who were female. In this particular case, it's going to be those two numbers there because these represent the females who were provoked and who were not provoked. So there is simple effect number 2 for set 2. So now we've been able to identify on our figure and on our table the comparisons of main effects, identification of interactions, and also looking at simple effects in these particular cases. Now, if you're wondering to yourself, okay, well wait, how is it that I can identify a main effect here on this figure? I'm going to go ahead and delete these circles, and we're going to look at the main effects for gender and then the main effects for provocation. Now, to identify the main effects for gender, so in other words, looking at the differences between males and female scores, remember, we had to create our marginal mean. So if you remember back over here, we had to create our marginal mean of 7.5 for men and 4.5 for women. So here, if you're wondering and you're like, well, where is 7.5 and 4.5 for men and for women? Well, it's actually very easy to find those numbers. How do we find those numbers? We look here. So if you look at this value here, that's a value of a 9 and that's a value of a 6. Going back to your table, that's a value of a 9, that's a value of a 6 that represent males. We took the average and it was a 7.5. Here, if you find 7.5, it should be right about there, right about in the middle of those 2 points. If you collapse those 2 points, it should be about right in the middle. We're going to do the same thing for females. It's going to be right about here, right about in the middle. Because remember, it was a value of a 6 and a value of a 3. Value of a 6 and a value of a 3 gives me an average of 4.5. Just about a 4.5. So if 5 was right about here, 4.5 would be right underneath it. So right about there. So now the comparison of this value here and that value there is the main effect for gender. So in other words, that's my average, my marginal mean for men, my marginal mean for women. Now, marginal mean for provoked and marginal mean for not provoked. Remember that my marginal mean for people who were provoked was an average of a 9 and an average of a 6. People who were not provoked, average of a 6 and an average of a 3. Marginal mean 7.5 for provoked. Marginal mean for not provoked 4.5. Again, now going back to our figure here, and again I'm just going to change my color of my marker one more time, and here I'll do I'll do like a pink color. We're going to do the exact same thing. We're going to collapse our points. So remember, this entire dotted line represents people who are provoked. That's a value of a 9. That's the value of a 6. I'm somewhere right about in the middle. So I'm right about here. That's my number right there. That's my average, my marginal mean for people who were provoked. Now, people who were not provoked, also somewhere right about here in the middle. Whoops. Somewhere right about here in the middle, which is my value of a 4.5. So it's right there on the same line as that blue one right there. So now the comparison of that number there and that number there is the main effect for provocation. So now you'll notice that on this graph, we've done everything that we have done here. Everything that we had done here on our table has now been done on our graph. So we've been able to identify main effects, identify if an interaction existed or not, and also identify the issues of simple effects. Now, one of the things that I've done is I've added in for you guys a little extra exercise that you guys can do for you guys to be able to identify main effects and interactions. There's a very interesting study that we commonly use whenever it is that we talk about this issue of interactions and when we talk about interactions and main effects. And I've posted them here on this lecture for you that looks at the last time that you ate with someone who's of the same sex and who's of the opposite sex. And I asked you a couple of different questions. So what did you eat? How much did you eat? And then this little narrative of some researchers in terms of what it is that they found in terms of our culture as to how it is that men and women interact in terms of their eating habits. And a little study of some researchers back in the 1990s who looked at this particular issue of eating and how it affects individuals' social presentations. Now, essentially what I've done in terms of these particular slides, I've given you the data, and what I would like for you to do is practice on yourself, practice on this data here, identifying which numbers you would use for main effects, for confederate, and for participant. Identify if there's an interaction, write down all the simple effects for yourself, and then as you're going through the slides, make your own line graphs plotting out your data so that way you can also follow along with these slides where it is that we identify main effects and interactions and everything like that. So here I've already given you all the answers to these handouts just so that way you can see what the simple effects would be. Also, you would be able to identify if interactions existed or not. and also identifying where main effects would exist here on these figures. All right. That wraps up our discussion associated with our discussion of factorial ANOVA. I know that our lectures have been quite long, but again here, this is more of just understanding the concepts, understanding where to look for the numbers, and here it's really no calculations of anything else except, calculating your marginal means and your cell means. But most of the time your cell means are already given to you. You just really need to calculate your marginal means and know where to look on your graphs and what to look for. So here, go through and really focus in on that issue of interactions because it's a very, very important issue. I hope you all have enjoyed these discussions. Please remember that your homeworks are actually going to be due on Sunday of this week. I've given you guys a little bit of extra leeway in terms of getting your homework assignments done this week. All right, so please make sure to look online for the due dates. And please let me know if you have any questions. Email me. Feel free to call me if you have any questions. Take advantage that you guys can call me and ask me any questions. We're approaching the end of the semester very, very quickly. And I look forward to your homeworks and to your discussion board post as well.